Everyone who's joining us today. I hope that everyone's enjoying in the U.S. A little bit of some quiet time or some productive time. I certainly have been enjoying it myself this week. So we are Zoomdata, and we're the company that's reinventing BI for a bigger, faster, and more diverse world. And I'm going to give you a brief introduction to why that matters, and I'm going to show you a couple of demos using maybe one or two different data sets, depending upon how much time we have. So we'll talk a little bit about why reinvent BI in the first place. We won't belabor it, but I'll just give you a little bit of an idea of why we exist. Talk a little bit about who our customers are, why they care that we exist, and I'll show you some demo, some with some fabricated demo data, and others with some actual real data. So why reinvent BI? And the answer is because the data changed, and so did the idea of the database. And in the beginning, and not way back, but maybe 20, 30 years ago, there were some production reports. These folks up here on the right, these are folks like you and me who had business questions, and we had to go through an intermediary who understood how the database was set up. These were very complicated, and to some extent still are. And that person would then create reports, run them overnight in a batch mode, create the reports, send them back to the person who said, hey, I have a question. And that, of course, would lead to more questions or corrections, and there was this constant cycle. Now, the databases that we had at the time, back about 30 years ago, were really the production systems. And what happened over time is we developed a way to take data off of those production systems, which was really optimized for fast inputs, transactions, and put them into a system that were better at doing large scans and saying, well, give me the aggregate number broken down by anything at all. So you have this multi-dimensional approach. And that's where you got this idea of cubes, which are super exotic when they first came out. And the folks up here were pretty happy. It was quite a bit of work to put together these data warehouses or these data marts, but when they were done well, they really did push things forward, and a lot of companies were able to really understand their business, their customers, their market, and make big strides forward. So BI settled in for a few decades, really. I'd say about 20, 25 years, things kind of went along this way pretty well. But then the data changed. So the area that we were talking about in the 90s and the early 2000s, you had maybe like tens of millions of rows, and it was structured data like I was showing you before, and there's relational databases. And then along came the web, and you had clickstream data, you had social interactions, so then you had hundreds of millions of rows of data, and they weren't always structured. So you've got this unstructured element coming in. And then you got into observations. So you weren't even just dealing with interactions, you were just sort of looking at the same thing, saying, pinging, I'm good, I'm good, I'm good, I'm bad. Well, what do you do with all that? So you've got tens and hundreds of billions of rows of structured, unstructured, streaming data. All this is where we're at right now. Okay, Chris, thanks for handling. Looks like we got a little bit of feedback. We good? Okay, I think we're okay. I'll keep going. Okay, so this new data landscape broke the BI model. So all these great BI tools have been built up over 10, 15, 20 years, and they were optimized for the old way of structuring data before we had this new landscape. And now you've got Hadoop, you've got NoSQL, you've got some really nice search databases, you've got tons of things going on with clouds, really excited, and then any number of other things that exist today and will exist in the future. And then, we folk up here are like, well, how do we get the information? We don't have access to it anymore. You might try to use a SQL type interface to get to one of these types of infrastructure, but it doesn't always work. And I'll talk about that in a minute. So what happens? You've got data streaming in at rates that we really hadn't seen up until, let's say, 5, 10 years ago. And then you've got folks down here who are really kind of doing the work that the report developers used to do, but these are even more sophisticated. These are developers who are writing in Python, they're writing AI scripts and things like that. These are the data scientists. And we're kind of depending upon those folks to find our answers to questions. But it's really not so easy. So there are a couple of problems that folks have up here. First one is just connecting. So not every one of these systems down here has a simple way of connecting to it. So that's barrier number one. But if you get past that, how long does it take for you to get information back from those systems? And it's not just the length of the query itself. It's like, well, what happens when you want to get the refresh or the update to that data? And then how do you visualize these massively large amounts of information? And then, oh gosh, what happens if you want to join these two together? Let's say you want to get information from a cloud system and join it to Hadoop or search. That's what this represents. So there's all this friction that is between the business users and these new environments where this new data is kind of living. These are valuable resources. What do we do about that? So kind of what happened with a lot of the other traditional BI vendors is they have this workaround. So you kind of are back to where we were before. The report writer is now an ETL expert who's taking information out of these valuable systems. They're putting them into the old type of environments that the BI tools are accustomed to, and then we can get the answers from within these environments. These are silos that are set up by this other person, and there's these extra degrees of separation. And boy, it is a lot of work. It's really not just one person. There's a whole team of people behind making this whole environment work. And it just leads to hidden costs. You end up with maybe not bad decisions, but not really fully thought out decisions. You don't have the full environment to work with. So you've got all the extra hidden costs regarding to modeling, managing, securing, and maintaining this sort of mediocre type environment. So why reinvent BI? The reason is that the data that we have, it's just too big, it's coming in too fast, and it's across a whole variety of different environments that are really custom created to handle this new kind of data that's coming in. So who cares? Well, the companies that are really trying to drive growth and innovation, they're trying to solve big problems, they're trying to do things with data that hasn't been done before because they have this new resource and they want to tap into it. They're trying to really move the needle. They're leaning into the future. And those are the companies who we have been most successful with. So the types of companies who are working with us, Meharry Medical is, they're doing some really interesting things. I really like talking about them. We were actually embedded in a product called ClearSense. And Meharry Medical is using ClearSense, which has Zoomdata embedded into it. And what they're trying to do is they're trying to achieve medical justice for an underserved community. So they're looking at data within a population that has not been traditionally represented in a lot of the larger medical studies. They're actually looking at the folks who are in their area, their locality, and they're trying to look at how they're going to serve that population. And the way it's been described is they haven't had the tools that lots of other larger organizations have had for years, and now they feel like they're actually leapfrogging some of these established environments because they're able to use the ClearSense product that has Zoomdata embedded into it. GSK, GlaxoSmithKline, they're using us to help bring life-saving drugs to market faster and at lower cost. So where their environment was predicting, say, 13 to 20 years, there's a big range there to get some new drugs to market. They're looking at doing it in 2. And what that means is that we're going to be able to find some drugs that will be able to actually save lives, and that's going to be a huge benefit to all of us. Government, so all of our tax money goes to the government, and one of the things that they do is they put a lot of that money into some very high-value public assets. Well, they are using Zoomdata to be able to analyze the information that's coming off hundreds, I don't even know how many actually, just a huge amount of monitors, giving lots and lots of information in a lot of the equipment that is out in the world being used to protect us. Cielo in Brazil, so they're basically the Visa of Brazil, and they're using us to get real-time market information. They put out a marketing program, and they want to be able to find out what's happening in real time. So they're using us to get some real-time updates so they can get faster customer acquisition and higher retention rates. And then another embedded scenario, we are embedded into a product called Cybersecurity Turnkey Solution. And this is interesting because when I showed you a little bit earlier, and I think I have a slide coming up where you've got the data scientists at the bottom contributing information up into the data environment, this is a good example of being able to sort of bridge that gap between artificial intelligence and machine learning. What we're doing here is that there's a whole environment that is actually detecting cyber threats and weaknesses, bringing that information into an environment, and then Zoomdata is able to actually surface that, and the end user can explore it to be able to basically secure their environment. And there's a number of other use cases. So telecom, finance, aviation, transportation, customer 360, and I have to confess, I forget what this icon is for. So really what we're all about, business intelligence, has always been trying to get the right data to the right person at the right time, but it looks a little bit different now than it used to in the past. So you've got your folks who are, oops, let me go back, who are trying to get directly to their data warehouse, whether it's going to be in Hadoop or maybe a cloud type environment, be able to work through some logs, for example, web logs, social interactions, any type of data mart, external information. And sometimes it's embedded, like I mentioned before, and sometimes it's not. And sometimes you've got some folks who are down here, the unicorns of the world, pushing information up into this new data environment that your end users can then take advantage of. So moving forward, again, we're trying to reinvent BI from the ground up. I will sort of skip through these two and get right into the demo. All right, so let me start. I'm going to show you some standard stuff, which you may see. Oops, sorry, let me get my username and password right. Okay. So this you might see on our website. You might have run into this in the past if you're accustomed to, if you've seen Zoomdata before. But what we're looking at is this is a 10 billion row database. And what you see here is something called data sharpening. Now, I want you to take a look at what's happening over here. It says reading 5%, reading 9%, 11%, 88%. And what's happening is that what Zoomdata is actually going to the data source. In this case, it's an Impala cluster, and we are predicting what the final value is going to be. And if you want to wait until the query resolves, which with most products, whether it's Zoomdata or not, will be about 2 minutes, you don't have to if you don't want to. And here's the thing about data exploration versus reporting. Reporting is actually meant to give you, like, this is the number. And exploration is really about, what is the outlier? What do I want to understand better? So for example, if I wanted to learn a little bit more about what's going on here, let's say I wasn't expecting this spike, I could, while the query is running, I can zoom into it and take a look at something entirely different. So I can zoom down into anything I want. In this case, I'll just choose, let's say, product category. So within California, it's now looking at the information and it's running a whole new query for me. And you can see over here that we're looking at about 10 billion rows of data. I'm not going to spend too much time on this one because I'm going to show you actually working with a product in another environment. But let me show you another, actually, let me get back to that. I do want to show you real time. I closed that out and it wasn't my intention. So here's a real-time example. So notice the time bar down here. So this is in live mode, and what we're doing is we are reading data that's just coming off of a live stream right now. And this could be anything that might be going off of, let's say, a Kafka queue or stream set, anything, you know, that's actually processing data. And what we expect is we take that data off of that stream and it should be landed. And the reason that we want it to be landed in environments, because then we can take a look at the whole background. So I can take this slider and I can scoot back as far as I want to the very beginning of the data set. And I'll show you an example of doing this with non-live data as well. So this is the data DVR. So I just wanted to show you that this is something that is possible if you wanted to look at data up to the second, if you want to delay it to the minute. Most of our customers who are looking at real-time data will be looking at it about 1 minute, but if you need it down to the second, you can get that. Okay, so let me show you some real data. This is a much smaller data set, but I want to give you an idea of the functionality of the product. So I have something backed up just in case I run into an issue. Hopefully I won't run into any problems. I'm going to do this from scratch. So the idea here is we're just coming off of a political season. We're not going to get into politics, I promise you. But there's some interesting things going on locally. So what I've done is I've taken some local political data, and I wanted to understand, okay, well, how much of the money and the contributions, comparing the actual dollar amount versus the number of people who contributed to some various local campaigns, what the distribution is going to be. So in this case, this is Montgomery County, Maryland, and these are 5 of the 9 winners of or elected officials who are going to be taking office for the county council position. Montgomery County has a little bit over 1 million people, and there was 5 open seats, 4 at large and 1 district council, and these are the 5 folks who were elected to fill those seats. So what I wanted to do is I wanted to see where the money's coming from, what might have actually contributed to the success of these folks, and maybe what they have in common. So here are the 5 elected officials, and by default we're looking at the count of contributions that they received. So I'm going to put in a few more things here. I'm going to add in some KPIs and just bring that up a little bit. So there's the count, and I will bring in another one, and this time I'm going to change the metric to the contribution amount, and I'll scoot that. Let me just rename this, and I'll scoot that up here. And you know what I can do? I can also duplicate or copy that chart. So let's say I had taken the time to change the colors or what have you. And this time, instead of looking at the sum, I want to look at the average. So all these are things that I, as a regular end user, can do. There's nothing special. I don't have to go back to administrator or anything like that. So I can see of these 5 elected officials, about 6,000 people contributed to their campaigns. They raised $1.75 million, and the average contribution was close to $300, which is a nice big chunk of money. Okay, let's do something else. Let's bring in a map. So now I want to see how this data or how these contributions were actually distributed. So again, I'm going to go in and I'm going to play with these things down here. And again, note that these are just sort of built into the application. Nothing had to be done by an administrator ahead of time to make any of this work. So I'm going to change the color from count to the contribution amount, just see what happens there. Okay, nothing really big there. Let me change it to average, see what happens there. Okay, now that was kind of interesting. So we can see that there were some big contributions, not only from out of the county, but out of state. We're going to come back and take a look at that. There's an interesting twist on this that I want to show you later. It's actually a really nice story. So for now, let's just leave it at that, and let's play with the data a little bit. Let me bring in one more look. This time I'm going to bring in a raw data table so we can take a look at the actual data that's coming in. And for folks who may be familiar with Zoomdata, this is version 3.7, which is going to be announced next week. So you're seeing a little sneak peek here. So if you have, let's say, 10 billion rows of data, in the prior releases, this might take an awful long time to load, but we've put some performance enhancements in here so that we're doing some paging, so it comes in much, much quicker. So let's take a quick look at the raw data table, seeing if we put some nice effort into it. Let me go in, and I'm going to configure this a bit. So I want the receiving committee is the name of the candidate. And a lot of stuff here I don't need. I don't need the contribution type. The address I've got in the map, county have the map, latitude, longitude. Maybe I'll keep the name, states, contributor type maybe. A lot of these things are represented in the map. So let's just keep this nice and simple. And we're going to take advantage of this in a little bit. All right, so let's do a little bit of playing around here. Let's go and take a look at Maryland. I'm going to zoom in. And this is the county we're looking for. So you can see within Maryland, there's a good amount of money that's coming from counties outside of Montgomery County. So I'm going to zoom in a little bit more. And we can see that the majority of the money came from Rockville. Now, I happen to know that that is because we used a public financing campaign, and all the money that was matched from the public financing contributions came from Rockland. So what I'm going to do, Rockville. So what I'm going to do is I'm going to remove that, add a filter, and I'm going to say contributor name, and I'm going to take out, let's see, yeah, maybe not there. Say contains Montgomery. And actually, I know that someone has a last name Montgomery, so I'll do that, Montgomery County. Okay, I did that wrong. Let me just, I did includes, I should have done excludes. Does not contain to apply. There we go, that's better. All right, so now we're looking at real people giving money here. So let's take a look at, let's say, one of these candidates. So we'll look at Andrew Friedson and, sorry, the wrong one, let me do filter. Now this is a nice little thing here. I can choose to filter everything on the page or just one, and I'm going to just choose to use the map right now. We're gonna filter everything in a little bit, but for right now, I'm just gonna filter the map to only show money that came to Andrew Friedson. So we can see that the average, the largest average came from up here. I'm going to change that just to the total sum. And we can see that most of the money came from the western part of the county. This whole area up here is agricultural. There aren't a ton of people that live up here. A lot of rich people live right here. So that's kind of interesting. So let's change this to, instead of some, actually I'll just leave it at some. No, I'll do a count. Okay, and most of his people came from Potomac as well, so that's kind of interesting. All right, I'm going to get rid of Andrew there, and let's look at someone else. So Juando, he was the big winner here in terms of fundraising, so I'm going to choose him, and we'll see how things are a little bit different. So he's from down in the southeast area, so you can see that a lot of his support came from a different area. Now, we can keep going through this and, you know, really kind of having fun with this, but I'm going to do something a little bit interesting. I want to show you a new feature that we introduced recently, and we've made some cool changes to with 3.7, and we'll wrap up for questions. I'm going to do something called creating a key set. And I'm not just going to create one key set. I'm going to create one for each one of these, and what I want to do is I want to see the overlap. I want to see who actually contributed to all of these candidates, for whatever reason. So let's just take a peek, and I'm going to call these Juando, and this is a way of doing some multi-pass analysis without having to go to a DBA and writing SQL. It can also do some really cool stuff. Let's see, this is Evans, and what I'm doing here, the data has been cleaned up and standardized. So I'm just looking at all the unique contributions from each one of these folks. So this will be Friedson. Oops, wrong one. I did not give the proper unique. I don't think I gave address here. Make sure I do that. And another key set. This is for Reamer. There's the address. And another key set. Gabe. All right. Okay, now I'm going to go up here and I'm going to put a filter across the entire thing. I'm going to add a filter, and this time it's going to be address, and I want to say key set is Evans. I'm going to create another filter. I'm going to apply Friedson, and watch all the data updating in real time. All those who also contributed to Gabe. On down. And Reamer. All right. So what we now have, we can see either through the map, we can see where we've got some folks who have contributed to all of the winning candidates. We could take a look and maybe try to understand where they're coming from. So here I'm going to make good use of the raw data. This is an attorney. This is an attorney. This right here is a state delegate. So we can continue to do this by maybe taking things on and off, maybe making some assumptions about which of these candidates or these elected officials might be more aligned with each other and so on. So we can do a lot of interesting things here. Now I'm going to go back. There's one thing I did want to show you related to outside money. And let me just pop this stuff out. Okay. Give me 1 second. What I want to do is in here, I want to create a new calculation. And this is something that's going to be new in 3.7. Let's say I wanted to split this by something that doesn't exist here. So I want to find out local versus outside. So I'm going to create a derive field. I'm going to paste this in. That's what I was doing a second ago. I'm going to say contributor source, put in an attribute, run the calculation, and now I can see that anything that's in Montgomery County in Maryland is local. Anything outside is considered outside. And now I'm going to do is I'm going to go into the chart style, and I'm going to add cluster chart, and I'm going to add contributor source to that. And I can see, again, that Andrew Friedson's campaign, 25% of his money came from outside of the local area. So let's take a quick peek at that. If I were to get rid of this and maybe only look at Andrew's stuff, some interesting things that you find out here. And this is going to end on a nice note, I promise everyone. Okay, remember how we went in and we looked at the contribution amount and we looked at the average and we had some weird numbers. We thought that the average was kind of high in Texas. Well, when you look at the details there and you actually look at who's actually giving the money, there's this big $2,500 contribution. Well, it ends up that this guy, when he was in college, contributed bone marrow to a man so he could survive. And in return, he has contributed to Andrew's campaign. So, there's a lot to be learned here in terms of being able to work with data, being able to understand data. The very fact that they were able to connect between Texas and Maryland 12 years ago, relates to the power of data and what you can do for it and how it can be used for good. So I'm sorry, we're right up. We've got 1 minute for questions. Chris, is there anyone who has a question that I might be able to answer?
Sorry, I couldn't find the unmute. Let's see. So I do have one here. And can you play a dashboard screen across time? Example would be monthly sales distribution across countries and for quarterlies, and then play for 18 months so one can see how it changes month by month.
Yeah, so in terms of getting into the details of month by month and so on, that's a little bit beyond my technical prowess right now to be able to answer that question. But what we can do, so this information has been timestamped, so we know the date of each contribution. So what I've done is I've taken my slide bar, my data DVR, and I've gone back. And I can actually play this information and see how the data actually gets played out. So we can see that there's 430 here. Let me just undo this. Andrew didn't have any data there. So we can see Hans Riemer was the incumbent. So he had the most support early on. So we can see the data actually building out. So if I go and move this forward, I can see where the contributions are coming in. So let me just zoom in a little bit. It's really kind of fun to see it when you look at the map view. All right. Oops. And go back. Oh, yeah, I chose Virginia. I didn't mean to do that. I got nervous there and I clicked the wrong one. So, but you can see the information building over time. Here we go. There's Maryland. Zoom in properly. There's Montgomery County. If I zoom in, you'll start to see the data shifting as you scroll down, move around. And again, if I were to remove Rockville, you'd see some really interesting numbers there. Let me just do this. I'll choose Friedson.
So while you're playing with that, do you have to have the latitude and longitude in order to map the data?
No, actually, so there's a different map that you can use for that. So let me pull that one in. Let me get rid of this guy. Delete that chart. And I'll explain what's required for each one. So I've got two different maps that I can choose from. The one you see right here is regions. And in order to get regions to show, you have to have a state. And if you want to drill down to county or drill down to zip, you need those two. But all you really need is state to be able to see the state distribution. Map markers does use latitude and longitude. And I was able to build that out surprisingly easy with Google Sheets. There's a script that you can incorporate in, and it will map the stuff for you, and then you just upload that to your database. So here you've got information. You see about 5,000 people have contributed money here, and you just keep popping in and see more and more detail. Any other questions?
We do. We have one last question, and I think we're running a little over, so just want to be mindful of everybody's time. How do you prep the data for use?
Oh, that's a great question. So yeah, you do want to really put some effort into it. And there's a whole variety of ways, and it depends upon what data you have and what you're trying to do with it. My data here is pretty simple. I could use Talend, for example, fairly easily, just the open source stuff to be able to clean it up. But if you've got data that's running in a stream like Kafka or StreamSet, you can actually clean it in the stream before you land it. We also work with, I'm spacing on the names right now. There's Paxata, and there's the T. It's a partner of ours, and I feel terrible. I can't remember the name of it right now. But there's lots of options there. And we do not do it directly, but it always helps when you're looking at data to have clean data. So when you want to reach out and talk to our folks in sales, just say you're interested in getting some help with that, and we can see if we can hook you up with a partner. It's a very, very important thing to do.
Awesome. Thank you so much, Mary. Thank you for this awesome and fun and interesting demo.
Okay. Well, thank you everyone for coming. I appreciate your time. I hope everybody enjoys Thanksgiving if you are celebrating in the US. And again, remember, data can do good things. So have at it. Thanks.
Thanks, everybody.